Hello everyone. Today in this video, I will tell you how to find out derivative of secant x and cosecant x using first principle. So let's see. First of all, let's see what is the definition and formula for finding the derivative of a function using first principle. Let y equal fx be a function, then its first derivative is the rate of change of y with respect to x, and which is defined by dy over dx equals limit h tends to 0 fx plus h minus fx upon h. It is also denoted by this symbol. By computing the limit of this whole, we can find out the derivative of the function, and which is known as the differentiation of fx using first principle. Now, what are the steps? With the help of the example, I will explain you the steps. First step is we will write down the formula. What is the formula? F dash x equals limit h tends to 0 fx plus h minus fx upon h. What we will do? We have its value. We have to find out its value, and we will substitute over here. Now find the value of this, because fx is secant of x. I will simply write it as sec x. F x plus h will be sec x plus h. X will be replaced by x plus h both the side. Now substitute the value. F dash x equals limit h tends to 0 fx plus h is sec x plus h minus sec x upon h. Limit h tends to 0 taking sec theta as 1 upon cos theta, so it will become 1 upon cos x plus h minus 1 upon cos x whole divided by h equals limit h tends to 0 taking LCM. It will be cos x plus h into cos x into this h, and it will be cos x minus cos x plus h. Now simplifying it, you will get limit h tends to 0 using the formula of cos c minus cos d. Using the formula of cos c minus cos d, it is 2 sine c plus d upon 2 into sine d minus c x plus h minus x upon 2, and this denominator will remain as it is upon whole divided by this as it is. Now f dash x equals limit h tends to 0 2 sine x plus h upon 2, 2x upon 2, that is x plus h upon 2 into, this will cancel out, sine h upon 2 and limit h tends to 0 over here, and this h is there I can write it as h into limit h tends to 0, 1 upon cos x plus h into cos x. These are multiplication of three terms. First term into second into third. Now substitute the value of limit. Here you can see it will become 2 sine x into, here we can see it is h by 2. I can divide it by 2 and I can multiply it by 2. And if h tends to 0, h by 2 tends to 0. And because we know that if theta tends to 0, sine theta upon theta is 1. But these three should be same. Only then its value is 1. So its value is 1 into 1 by 2 as it is into 1 upon cos x into cos x. That is sine x upon cos x. I can write like this into 1 upon cos x. That is tan x into sec x. So we concluded that derivative of sec x is, what is the final answer? Derivative of sec x is sec x into tan x. This is our. Let's take one more example. Derivative of cosec x. What is the first step? We will write down the formula. Limit h tends to 0, fx plus h minus fx upon fx. Second step is we will substitute the value of fx and fx plus h. Because fx is cosecant x, that is Cosec, we simply pronounce it as Cosecx. So fx plus h, replace x by x plus h, replace x by x plus h. It will become fx plus h equals cosec x plus h. Substitute the value over here. Fx plus h is cosec x plus h minus cosec x upon h. Now let's take the second example. Fx equals cosec x. How to find out its derivative using first principle. The first step is number 1. We will write down the formula. F dash x equals limit h tends to 0, fx plus h minus fx upon h. What is the second step? In second step, find out the value of fx plus h fx. Fx is cosec x, fx plus h will be cosec of x plus h. Substitute the value over here. Limit h tends to 0, cosec x plus h minus cosec x upon h. Now substitute the value. Simplify this. f dash x, limit h tends to 0. We know that cosec theta is 1 upon sine theta, that is sine x plus h, minus 1 upon sine x, whole divided by h. Taking LCM, it will be sine x plus h into sine x, and this will h come over here, and it will become sine x minus sine x plus h equals limit h tends to 0. Sine c minus sine d, using the formula. Sine c minus sine d, using this formula, it will become 2 cos c plus d by 2 into sine c minus d by 2 upon this whole denominator will remain as it is over here. Now the next step, simplifying it more, limit h tends to 0, it will become 2 cos x plus h upon 2 into limit h tends to 0. This will cancel out, and sine minus theta, sine minus h, sine minus theta will become minus sine theta. We can substitute minus sign over here. So sine minus theta will become minus sine theta, that is minus sine h by 2 upon h as it is, into limit h tends to 0, 1 upon sine x plus h into sine x. So there are three terms. Number one, this will become this, into sine minus theta, that is minus sine theta, that is minus sine of h by 2, and this h we will take over here, and denominator limit h tends to 0, sine x plus h into sine x. Now finding the value, what we will do, we will take it as h by 2, means we will multiply and divide by 2, and this limit will also become h by 2, because we know that limit theta tends to 0, sine theta upon theta is 1 if these three are same. And here we can see sine h by 2, h by 2 and h by 2. So its value will become 1. So finding the value of the limit, substitute the value of limit, we will get f dash x equals, it will become 2 cos x into minus is there, and 1 upon minus 1 upon 2. This minus sign and this 2. And its value will be 1 into 1 upon sin x into sin x. F dash x will become 2 will cancel out. Cos x upon sin x minus sin is there into 1 upon sin x. This, that is minus cot x into cosec x. So if fx is cosec x, its derivative is minus cosec x into cot x, and these are the steps to find out its derivative using first principle. That's all in this video. Thank you for watching.